Can you hear me now?
I can.
Yep.
I can't hear Norm. I can't hear anybody.
Really?
You don't hear anyone?
Hello?
Hello?
Okay, I'm going to switch back to the other set.
I'm going to wait to let people in until we're done troubleshooting.
Okay, is that working now?
I can hear you. Can you hear us?
Yeah, I can hear you now.
I can hear you guys.
Okay. Good, good.
All right. Hopefully,
All right.
Am I clear or am I still breaking up?
You're clear.
I think it sounds pretty good now.
Okay. Part of it may be that I've got this background on and it's chewing up bandwidth.
I'm going to start letting people in if you are all ready. Good? Okay.
I'm
I'm
ready.
good.
All right. Welcome, everyone. Apologies for the delay, having a little bit of tech issues. I think we are good now. Thank you all for joining us. Housekeeping, make sure that you have both your first and last name listed in the attendance sheet, not your company name. That's helpful for the AIA staff as we are reporting your continuing education credits. I know sometimes by default, your accounts will log in with your company or organization name. So please just make sure that it reflects your first and last name so that we can get those credits to you. With that, I would like to turn things over to Carly Davis with Langen. Langen is a session sponsor for this session today, Small Town EnerPHit, the Wilds. And with that, Carly, I will turn it over to you.
Hi, everyone. My name is Carly Davis. I'm with Langen here in the Pittsburgh office. For those of you, I recognize several names on the call right now, but for those of you who don't know me, I'm one of the project managers at Langen in the site civil department. And for those of you who don't know Langen in general, we are a multidiscipline engineering firm with site civil, geotech, environmental, traffic, GIS, surveying, landscape architecture, kind of a one-stop shop from the ground down. Then we take it over to you guys for the ground up. So we as a company have been in business for over 50 years. We celebrated our 50th anniversary last year. And we have over 36 offices nationwide, just opened up 2 new offices, one in Austin, Texas, and one in Chicago, Illinois. In the area, we are working on some of the largest development projects. We work on a lot of things downtown, a lot of warehousing out in some of the more rural areas, which is really where I kind of focus more on. But we do a lot with land development projects, real estate portfolios, and a lot of things in energy as well. So that's just a little bit about Langen and our kind of nationwide experience as well as local. So today, I'm going to kick it over to Gary and Norm to talk about Small Town EnerPHit, the Wilds. We're happy to be here.
Okay. Do I just start, I guess? Can everyone hear me?
We can.
Okay, good. Good, thanks. Well, welcome, and we'll get started here with our presentation. Oh, wait a minute. Got out of sequence here. Just a second. Share screen. There we go. Okay. All right, welcome. Today we are going to be looking at a project in Kane, Pennsylvania, and I guess this is sort of the boilerplate information. We're provider number A217, and our Learning objectives for today, we're going to learn how high performance projects impact the local economy of small towns. We're going to learn how to work with a regionally distributed team, some techniques and details that can deliver passive house performance in a 130-year-old building, which is a challenge, and some of the challenges that we've met and some of those that we just are a little insurmountable for us. A couple of folks are going to be joining me today. Joel Morrison, Brandy Shemp, and Kate Kennedy are all going to be joining via a video that I'll be playing here in a few minutes. Kate and Joel are going to be online a little bit later for the Q&A session. And Norm Horn is my partner in crime here as far as construction management. So he'll be doing a little bit more of the presentation here a bit later. First off, I want to acknowledge that our project team here. Of course, nothing happens without clients, and without the vision and persistence of Joel and the West Penn Power Sustainable Energy Fund, this project really wouldn't have happened. Challenging projects are only become possible with good partnerships, and Norm of Invinity has been our third leg of the stool. His experience and insight has been invaluable all the way from the initial concepts. Norm is dual credentialed as both a certified passive house consultant and certified passive house tradesperson. And as I said before, you'll be hearing from Norm a bit later. The rest of the team, we're fortunate to be partnered with InScale Architects out of Warren, Pennsylvania. Donna Zerkney has been our eyes and ears and boots on the ground up in Kane. She has a good relationship with the local authorities and the contractors that are working with Norm. And it's really allowed our project to move ahead, especially when I wasn't able to get up there due to either COVID restrictions or weather. Donna is also in the process of taking the Certified Passive House Designer class online, and she'll be taking the exam, I think, next month. So she's been helping us to transform the market in Northwestern PA. And Michael L. Norris Associates is our mechanical engineer. They're out of State College. Mike has a history of doing a lot of renewable energy and high performance work. And then we added the additional challenge to him of doing passive house. And he's risen to the challenge, has really done a great job embracing the technology and the whole passive house approach. And last but not least, Dave Brace at Brace Engineering has helped us figure out how to keep things standing and sort of bolster up the structure for another 130-year run. So with that, I will start a video.
Hi, I'm Joel Morrison. I'm the Fund Administrator for the West Penn Power Sustainable Energy Fund. We're a 501c3 nonprofit established in roughly 2000, and our mission is to promote renewable energy, energy efficiency, and what I call the 3 E's, environmental betterment, education, and economic development. We're here today to learn about the Kane Passive House, which is one of our projects. But before we talk about the technical details on the project, I think it's important to put the project in context with the local community. So what we'd like to do now is talk a little bit about Kane, the community, and how they perceive the project.
Hi, my name is Brandy Shemp, and I am the mayor of the borough of Kane. And on behalf of all the residents here, I'd like to welcome you to our community. And I'm here with my good friend Kate.
Hi, I'm Kate Kennedy, and I'm the director of the Kane Area Development Center, which supports the Kane Chamber of Commerce, our revitalization organization, and our industry development corporation. And we're
thrilled to be partnering with the West Penn Power Sustainable Energy Fund, who took an interest in our community a couple years ago and has now committed to a full-blown passive house building right here on Main Street, which is historic Route 6. We're in Kane, Pennsylvania. We're located in the northwestern corner of the state. We are rural, but we are moving forward and pushing ahead. We border the Allegheny National Forest, and we are often known as the Star in the Forest.
So we're a town of about 3,700 people, and as Brandy mentioned, we are a rural community. And rural sometimes gets a bad rap, but the Passive House project really shows our innovation and the way that we embrace forward thinking. And this is nothing new to Kane. Our founder, Thomas General Kane, was very forward thinking and innovative himself, as well as some of the people that have lived here throughout the years, including Dr. McCleary, who brought a species of endangered wolves to be saved here in Kane, PA. and those same line of wolves are continuing to be protected to this day. So taking action and being really forward thinking and innovative is nothing new to us, and we're really excited to represent rural Pennsylvania in this.
Yes, we're very excited to have the Passive House here, and their partnership has been really, really wonderful because they have really embraced the momentum that's happening here, the revitalization efforts that are happening here, and they've really actually taken this step further to work really hand in hand with the contractors and to educate them. And through that education, now our local contractors can use best practices as they work on other revitalization projects up and down our main street and in and around our community.
And that's a really big deal because education is a talk, but they also showed it by doing this education for the contractors, which will leave an impact for generations to come. And not only is the Passive House going to be something that's great for our local community, but it's also going to be a point of interest for tourists and people who are interested in this type of work to come and visit Kane when they might not normally do that. So the value of the tourism that this could bring to our community is a really huge deal for us.
Okay, now we're going to ask each other a few questions to give you a little bit more insight on our community and how this project is positively impacting it. So, Kate, first, what are some of your feelings and thoughts surrounding Kane and the revitalization happening here?
Well, I love Kane, and I actually moved back just 2 years ago because of the momentum and the excitement that's going on in Uptown and the surrounding areas here. So we have what's called an alumni weekend where alumni from as many years back as can go come together in the summer, and I think that really captures our pride. And our alumni weekend's coming up in June, and I'm so excited for them to see the Passive House project because I think everyone's going to be even more proud of where they come from. So Brandy, will you share your feelings about what you experienced when you learned that 63 Fraley Street was going to be built to Passive House standards?
Well, in the beginning, I was just thrilled that the West Penn Power Sustainable Energy Fund had committed to buying a building in Kane and had committed to the renovation process. And at that time, I was just thrilled. It was even more thrilling to learn that they had then voted to make it into Passive House standards. It was one thing to hear that they were going to make it into Passive House standards, but it's another to try and understand what does that actually mean. And so it's been a really great learning process. They're very hands-on. They're very happy to show you, happy to educate you. And as someone who owns buildings along Main Street myself, that pieces for energy sustainability, heating and cooling, and all of those things, because while a lot of these buildings have great facades, it really, you need the structural integrity and you need to have things on the inside that matter too. So it's been a really great process to learn. So one of the things that we work on really hard here is sharing our story and telling people why it's such a great place to live, to grow up, to visit. You should come visit. If you like the outdoors, this is an absolute adult playground. We have so many great things going on here, and we're attracting people of all ages to come back to either invest, second homes, camps, there's hunting, fishing, all of those great things. So we'd love to come, have you come visit and see what our momentum is all about. And Kate's going to tell you a little bit about the economic end of the development.
Over the last 5 years, we've really seen a revitalization. So it's important to mention that there's been many people hard at work forever, keeping their businesses going, even during the hard times. But over the last 5 years, we've seen more businesses open than we've seen in a while. In fact, almost 25 new businesses have opened in that time period. And of those, 6 of them opened during the COVID pandemic, which I think says a lot about our community. In fact, I don't believe any businesses in Kane closed during the COVID pandemic due to COVID specifically. So we're really excited about the energy and the pulse that's going through our town right now and want you to come experience it for yourself. There's great places to eat. We have a brewery, a distillery, and a winery right here in Kane. So no matter what you enjoy relaxing with at the end of the day, we have something for you. And as Brandy mentioned, we're in the PA Wilds, which is a gorgeous region of Pennsylvania. So we invite you to come and experience everything that we have to offer here in Kane. And of course, take some time to get a tour.
It looks like we may have lost Gary. Hey, Norm, do you have the presentation that you can pop up until we get him back in?
I do. I have my presentation, which is meant to go after his. I mean, if we can't get him back here, I can tear into it. It might be a little bit out of sequence, but I think we can probably make it work.
Yeah, I think that might be okay until we get him back. If you want to start getting it up onto the screen, I feel like he may have had some Wi-Fi issues, so it might be a few minutes.
Yeah,
Sorry,
that
everyone.
that was getting pretty rough there. For okay, let me see. Okay, everyone able to see my screen there?
Yes.
Okay, good afternoon, everyone, and thanks for bearing with us while we had a little technical hiccup there. My name is Norm Horn. I work with EnerPHit up in State College, Pennsylvania. We're a design, build, construction, renewable energy, and mechanical engineering firm. So I'm Passive House Institute certified Passive House consultant and tradesperson and the construction manager on the project. So I'm going to talk about a more detailed look at some of what we've been doing up here in Kane since last fall. I'm going to start with a quick overview of the major envelope and structural components, and then take a closer look at how we tackled the air barrier on this masonry retrofit project. There are a lot more construction activities happening that I'm not going to cover, like interior restructuring and framing or elevator, because what I really want to focus on today is how the Passive House methodology plays into the bigger picture. And I see that Gary's back, so I really kind of want him to run through his section here. So I think it'll make, if he's back with some good bandwidth, I think that'll make everything flow a lot better.
Yeah. Hi. I'm sorry about that. When did I drop out?
I think it was right at the end of the video, Gary.
Okay. Well, the video wasn't over. So
Oh,
did you catch Joel starting to talk about the building?
We did
I
not
will-
get that far. No.
Okay. I lost audio about 7 minutes into the video. And so I guess, okay, well, I guess we'll just sort of pick up. So I'll pick up with my, with mine, share screen.
I had asked Norm to get started. He didn't get
Yeah.
very far while we were waiting for you. So
That's okay.
we're glad to have you back.
All right. Sorry about that. I don't know what's going on. I did have some earlier troubles yesterday with Zoom. So, or earlier today with Zoom. All right. Well, let me pick back up where I was. Okay. So here's the basically the crew. Are you seeing my screen? Are you seeing?
No, not yet.
Huh. Oh, share. There we go. All right.
There it is.
Okay. And now you should be seeing the full screen slideshow.
Yes.
Okay, good. All right. So that's a lot of the folks that are involved with the project up in Kane. They just took this photo yesterday in front of the building. So let me give you a quick overview. Kane is located in northwestern Pennsylvania, about 130 miles northeast of Pittsburgh. You can see it right here. It's on the edge of the Allegheny National Forest. And I think you may have gotten the part where they were talking about the size of Kane. It's about 3,700 people. Kane is located on the tribal territory of the Haudenosaunee peoples and also in the Erie-speaking peoples. As far as the site and context, this is what the building looked like here on the left-hand side is what the building looked like when we walked up a couple years ago here. And it was the former Moose Lodge. It had been built as a two-story building in the 1890s. expanded over time to a 3-story building, expanded out the back a couple of times. Basically, this building here our building was built first. Then the bank building was built next to it, party wall situation. They basically built 3 stories piled on top of our wall. Same thing happened on this building next door. They basically took it up to 3 stories. And then when the 3rd story was added to our building, they spanned across with steel I-beams in the 20s and basically built the 3rd floor as a clear span structure. The interior structure of the building is all wood. It's hemlock, probably from the original old growth forest that was cut down in the late 19th, early 20th centuries. After that old growth forest was cut down, the sunlight hit the forest floor and hardwood started growing. So Kane became known as the black cherry capital of the world. They still grow most of the black cherry that gets used in the US, actually throughout the world, as well as oak and ash. And we have plans to use actually all 4 sources. We're going to be using a good bit of the reclaimed hemlock that we've taken out of the roof structure, as well as ash, cherry, and oak from the existing from the area forests. Here's some of the other context across the street, or next door. You can see we got this beautiful old bank building, sort of a Sullivan-esque. Really nice, nice fine stonework and terracotta work. Not such a sensitive job of the window replacement. And then across the street, we have some really nice old buildings that are well preserved, Victorian examples, and some that are not so well preserved. But basically, it's a very nice little downtown. There are a couple of brick plants in the area, so there's a lot of brick, and of course, then the timber on the structure inside from the era. Here's some old historical context. You can see here on the right, this is in the photo on the left, but on the right-hand side, this was the original building at 2 stories tall. This was at some point after the other 2 buildings were built, so probably somewhere around 1910 when this photo was taken. And it was before the 3rd floor was added. And then this shot looking the other direction from the 60s. You can see at that point it's a 3-story building with kind of the nondescript facade. Already had the permastone added on the and was the Moose Lodge at that point. And here it was sort of an aerial shot. We have the good fortune of having a video production facility across the street from the project, and he has several drones. And he's actually been engaged by West Penn Power Sustainable Energy Fund to actually he did the video that we just saw and has been documenting the project. Will continue to do so as we go through. So this is one of his drone shots. You can sort of see where we are on the street and the general context. Some of the existing conditions, I think Norm probably already showed you these. These were his photos. You can see the masonry was in pretty rough shape when we started. Also, the wood floor, we were the old structure had a bearing wall going up the center, so it was basically a 2-span structure with full 2x12, 3x12 joists spanning, roughly 20 feet to the middle. It's roughly a 40-foot wide building. Needless to say, that didn't quite meet our current codes for floor loading. So one of the things we did is we turned it into a 3-span building. We added 2 lines of columns and beams going front to back to shorten the spans up and replace damaged wood you can that we occurred over the ages from people cutting things up, as well as water and other damages. So you can see here's what the inside of the building looked like early on. This Kane Bank and Trust building that's up on the 3rd floor on the side of the building from when it was, before the 3rd floor was added. Down on the 1st floor, this was the back of the original building, and you can see they added about 20 feet behind. And then I think this other photo is on the 2nd floor, just showing some of the brick walls that were there on the party wall. Norm's going to get into some of that later as far as what we did with the brick walls. So you can see here existing conditions. We have the party wall down the middle, stair going up the center, and the basement was just the original footprint. Fairly low basement. We're really just using it for some mechanical work, and we'll talk a bit more about the envelope strategy here in a bit. And you can see pretty straightforward sections and elevations in the existing. So our design parameters for the new usage was basically to come in, do retail on the first floor, not a restaurant. We were fairly clear that we did not want to get into hoods and water usage and so forth with a restaurant. There's also enough other buildings with restaurants on Fraley Street. We didn't really need to get into that. The second floor would be multi-tenant office space. And the third floor would be a conference room, classrooms, essentially operated by West Penn Power Sustainable Energy Fund for the community benefit. So it becomes a nice big meeting space since we have nice big clear spans. Rest of the mission statement, we want to be a good neighbor. We want to set the example, as they were talking in the video. You know, we want to demonstrate how to do this and you know what can be done in transforming the market. We wanted to share an elevator and a stair with the building to the south. We call the Laughing Owl Press. That's the name of the business that's in there. They did not have an elevator and they were short a stair to be able to use their floor plate. So we figured if we could double up, use some of the sliver building ideas that have been pioneered here in Pittsburgh and sort of take those up there. So we've been working with a local code administrator to you know, do the administrative variances to be able to do that. We wanted to use local and regional materials. We also wanted to salvage and reuse whatever we could. Generally wanted to decarbonize through both using the embodied energy of the existing building as well as reducing our operational energy usage. And then also transform the market. We wanted to demonstrate the passive house approach, passive house techniques. We wanted to train the professionals in the trades up in that area and also develop some of the supply chains for the materials. And further, we wanted to follow the PA Wilds design guide. It's part of a, you know, as Mayor Brandy was saying, it's part of the PA Wilds, and they do have a design guide to help promote renovation and redevelopment of the downtowns that are in the PA Wilds area. And essentially the parts that that we're working with is using the context of massing materials and historic imagery, and then also use of local materials. Joel is a geologist by training and pretty much mandated from the get-go that we use stone in some big way. So we're using stone actually from Russell Quarry in Grampian. And then to maximize daylight and views, you know, since we are a sliver building east-west, the building's 40 feet wide and about 120 feet deep. And so therefore trying to get the daylight into the narrow ends is one of our key goals here. As far as the passive house, at very minimum, we were tasked with hitting the passive house EnerPHit performance. And these are the parameters for that: 1 air change per hour at 50 pascals, 9.75 kBTUs per square foot per year space heating, 4.75 kBTUs per square foot per year for cooling. We have a primary energy demand limit of 38.04 kBTUs, and with renewables, our limit is 16.17. And that translates, since those are primary energy, basically the site EUIs translate to 12.68 and 6.3 or 5.39. So pretty low energy usage. And of course, then the last piece of passive house is the thermal bridge free. We didn't really have any other formal metrics or systems that we're going after. We talked about doing possibly LEED, possibly WELL. We're sort of cherry picking various aspects of those. Generally, we're adhering with the LEED, IAQ, and material standards to the extent that we can, just to have a good, healthy building and to you know, reuse the building, reuse materials, and you know, use local materials. Timeline started back in June of 19 when they bought the building. They spent the first couple of months working with InScale to document the building, develop some conceptual designs, sort of figure out what direction they wanted to go. And then in October of 2019, the board, headed by Rob Hoskin at the time, decided to go for a passive house, and they engaged us and Invinity to help them get there. We started our PHPP modeling, you know, towards the end of 19. We basically set a deadline for mid-April to get our core and shell CDs out. And then, of course, the work from home order hit us just before our DD deadline. So we kind of did a shift in what we were doing. We were able to issue masonry repair and stabilization package in May, and then full full-ish core and shell documents were issued in June of 20. And then let's take that slide out. So anyhow, here's where we are today as far as the design goes. The front of the building, we've developed a stone facade using a clip-on system, 1.5-inch thick stone panels held on a clip system over about 6 inches of rigid insulation and an air barrier and rain screen arrangement. All of the front windows are a Rayco timber frame curtain wall. We have big pieces of timber frame around each window opening, as well as holding up the main curtain wall. This is a triple glazed, thermally broken curtain wall system where the back side is timber, the front side is traditional aluminum curtain wall components. We have a little canopy element on the front, which since we do have a lot of bifacial solar on the roof, we're planning to put some bifacial solar here just so people can sort of see what they look like. And then we have these monolithic posts or columns holding up a timber frame and galvanized canopy support for that. Little planter area shielding the accessibility ramp. The site does slope slightly from north to south, and we've got about an 8-inch floor difference from sidewalk to first floor that we had to make up there. On the back side, we extend past the neighboring buildings to a varying degree, 20 to 30 feet. And what we're looking at back here again is rigid insulation over top with a underneath a metal siding. So this is just a ribbed metal siding with vertical ribs on the upper part and horizontal ribs on the lower part. We've got a little heavy timber canopy here over the back door, windows into some office space, and then our VRF units are sitting here on the back of the building. Plan-wise, you can see here we're bringing doing our core essentially along the south wall of the building. So the main entrance is here. We work back, elevator, mechanical, a shaft that goes all the way up through the building, stacked toilet rooms, some service space here. This varies between electrical, kitchenette, and storage on the various floors, and then our back stair here. The alley is about 3 feet higher than Fraley Street, so we had to make up that difference in the stair to get out the back. You can see here that this is the Laughing Owl Press building. We're poking through the party wall to provide access to the stair and the elevator. And then what that does is that gives us a nice wide 24-foot by 115 swath of space. Get good daylight penetration from the east with the big windows. Pretty good daylight on the back. These were the existing openings, plus being on the west side, we were trying to not get huge openings on the back just to prevent some of the overheating. But on the front, we didn't feel too badly about bringing in some of the cooler morning light. So you can see that same idea just sort of goes all the way up through the building. Section wise, we peeled off the old roof, and Norm will get into some of the mechanics of that later. We had these 18-inch deep steel beams, basically 16 on center, that were marching back along the third floor, and we set up a series of trusses to give us a monoslope roof to the back. Got rid of an old bad drain system, so we're basically keeping all the water outside the building. We've got a huge gutter on the backside, and this gives us a nice high space. The other thing that we've done by popping the roof up, we first of all got a parapet, so we had a little more distinction from the neighbors instead of having the same height. And by bringing our roof up, we were able to extend our parapet around and cap over top of the party wall, giving ourselves a good air barrier and also a good thermal bridge free. Actually, we have a negative thermal bridge, a negative psi value all along that edge. Our roof is our largest exposed exterior surface, so we really wanted to get it right, get it complete, and get those big long edges covered well. And Norm's got some good photos he's going to share later with the construction. And then here's the renovation. Of course, here's our stone facade. We've got a little stone framework around the curtain wall, And then on the back side, we've got our ribbed metal cladding system. The roof, in addition to being our largest surface, is also a power plant. We've got 90 some 430 watt PV panels planned for there. They may actually be closer to 500 by the time we actually get installed because the technology keeps advancing. We also have our energy recovery ventilator sitting on the roof, and we have a roof hatch so that we can come up and maintain everything and actually, you know, show it off a little bit so if people want to venture up the ship's ladder to the roof. So basic design elements, we had new roof structure that extends over the party walls. We used a fluid applied air barrier on the inside of the walls. And Norm's got some good photos of that he'll share with us. The new front wall is completely insulated. In addition to the 6 inches of continuous, we have about another foot of rock wool in various stud cavity spaces that make up the front wall and that work within the structural frame. We have also on the interior, wherever we transition from party wall to clad wall, we've had to do some transitional areas of overlapping insulation on the inside and at the corners to get rid of our thermal bridges at the corners. And then at the bottom, the first floor, we've actually created a thermal envelope at the first floor level. So the basement is outside our treated floor area. We've basically got on the floor surface, we've got the old wood decking under that, blown in fiberglass insulation with an additional air barrier below that. And and then we've got Durock on the bottom, providing a fire separation to the basement. As I said, the triple glazed curtain wall on the front is a Rayco. On the back, we're using Ventana, made in export PA, triple glazed UPVC windows, and then we've got the PV on the roof. So is that right? Yeah. Okay. So where are we? In summary, right now against Passive House, our criteria is 9.51, but you can see we're at 3.16, which is actually under the 4.75 space heating demand for Passive House Classic. And similarly for the space cooling, our space cooling is 4.75, which is the same as Passive House Classic, and we're well under that. Our air tightness right now, we're carrying 0.1 or carrying 1 air change per hour as our factor, just because we're allowed to under EnerPHit. But if we can get that under 0.6, which Norm will talk about a little bit later, then we're in good shape for Passive House Classic. And similarly, our primary energy goal is well in hand, and you know, that number doesn't change much actually when we go to Passive House Classic. So we're actually in very good shape to hit true Passive House Classic and not just EnerPHit. And then here's, you know, sort of the same numbers, you know, slightly differently presented. You can see our renewable energy is around 53 kilowatt hours per year. And you can see our EUI here is looking pretty good. So I guess so in summary, we're on track with our PHPP. We're on track for hitting Passive House Classic, or actually Passive House Plus, and we're still projecting, you know, substantial completion at least for the first tenant sometime this fall, and possibly for the full building after that. So I will turn it back over to Norm and let him pick up where he was.
All right, thanks, Gary. I'm gonna share. Okay, so we're back to where I left off briefly. I'm gonna get into a really quick review here of the existing conditions that we started with. Let's see. So, you know, as Gary mentioned, we had approximately 12,000 square feet of floor space over this 3-story building, bounded on the north and south sides with shared party walls, and the east and west facades are and were 3-white brick. Wood floors, roof assemblies bearing mainly on the party walls, but with some point loads on the front and rear facade elevations. And we talked a little bit about the sequence of the original construction and the challenges that presented for us. You know, so we started out as a 2-story building. Our neighbors went up and they built 3-story buildings with their 3rd stories on top of our parapet walls. And then, you know, 15, 20 years later, so our building came back, added a 3rd story, doing the same thing. They dropped these big steel, 18-inch steel I-beams into the neighboring buildings and put a roof on it. And then there's another addition off the back of the building into the alley. And some of that was uncovered as we did the demolition. It found like a 4-white wall, like right in the middle of the building, basically. So, you know, the strategy for the renovation here was, you know, to remove the front facade because it was structurally starting to present some problems, and it was full of small punched openings that just weren't going to work with the design. Replacing the entire roof structure was something that absolutely needed to happen because the roof was well beyond the end of its life, and we needed that extra structural capacity for a PV array up there. Here's the roof. The first time that I came to the site, it was pretty bad. And then here's the 3rd floor. When we got started, you can see those big steel I-beams up there, pocketed into the neighboring buildings. So we had 2 big tasks to start this project: the roof and the facade replacement. So as probably most of you remember, you know, Pennsylvania closed construction for 9 weeks at the end of March last year. And, you know, other businesses were forced to learn how to work remotely with no advance notice. So things got difficult quickly. When we started to reopen awkwardly in May, and by the time Gary's office had gotten core and shell drawings done, we got a permit issued, contracts lined up, materials secured, we had a really tight window to get this done, starting in August, and trying to get both of those assemblies completely replaced and dried in by mid-October, when snow is a very real possibility in this part of the state. So we came up with a way to work on these assemblies concurrently. Here you can see, you know, a small crew of masons dropped this facade in just a couple of days. And, you know, so we had some temporary support and weather protection on the inside here. And once they got that down to the sidewalk, they just kept going and went into this 2-foot thick sandstone foundation wall and set new piers that our new facade structure would sit on. So we used a local steel fab shop who really kind of blew us all away with the level of detail and quality of work that they delivered, on top of having to navigate, you know, borough approvals and I don't know how many PennDOT permits to transmit or transport the steel, and then shut down Fraley Street, which is, you know, a state route and the main street through town. So we had the street shut down for a day and a half, and that allowed them to set these 2 58-foot towers. They did in one piece, drop them into place. You can see the second one going in, and then they connected them with a few beams right down the middle to complete that structure. Here it is at the end of the day. They had the whole thing up and largely tied into the neighboring buildings and tied into our building. So while that was being fabricated, the roof structure was being replaced section by section. So the steel I-beams are roughly 16 feet on center. So that let us take out the roof in 16-foot chunks and just sort of march down the length of the building. So, you know, as we said earlier, the 3rd floor was a pop-up addition supported with those beams. And the roof assembly and, you know, and how it connects to the walls is where the discussion of air and thermal control layers really starts to get interesting. And we wanted to use the roof deck as the air barrier, and intended to keep as much, if not all, of our roof insulation outboard of that structure for solid continuous insulation. So we removed the rafters and the little stud walls on top of the beams and replaced them with open web trusses to span the roughly 14, 16 feet between. So here we are. We started one bay back from the front, and then took off the front section last. So our gable end trusses were sheathed with zip R sheathing, which gave us an air barrier and a layer of R9 polyiso insulation bonded to that zip sheathing in one panel. And we taped the seams and the perimeter of each truss from the outside as they went in, as well as then taping them to each other. And that gave us a way to jump our air barrier from the outside around the parapet and down into the inside of the building. We connect that later when we pick up the air barrier with our inside masonry walls. So here we are after a fresh set of trusses on top of these 2x8s that basically just held up a plaster ceiling. And these are the ones that we salvaged several hundred of these. Hopefully we can use them in the rebuilt structure. So here we are after probably about the first 4 sections, looking from the back to the front of the building. And it took them, usually it was about a day, day and a half to get a section torn off, and then about 3 or 4 hours to set the new trusses. And here we are. This is the day right before we set that steel structure. We had a good weather window and an opportunity to take this last bit off and have it ready for eventually tying into the steel. And then here we are with a complete roof deck and air barrier. So once that was done, we were able to turn our attention to roof insulation and the membrane. So we went with a white TPO membrane with the thought that the extra reflectivity would benefit our solar array, which currently scheduled to be 102 435 watt LG bifacial panels. Those are modeled to generate about 51,000 kilowatt hours per year. And Gary was able to work the PHPP energy model to give us a continuous 8-inch layer of polyiso across the roof deck without needing any additional insulation inside the building. These are some of my favorite construction nerd photos that really show how this roof assembly went together. So each layer, from the air vapor barrier, two layers of 4-inch polyiso, some tapered polyiso at the edge, a cover board, everything we adhered with calf grip instead of using any mechanical penetrations, because we really needed to avoid that if we're using the roof as the air barrier. It's kind of hard to see in some of these photos, but we actually flew the roof deck long over the parapet walls. See, this shows up in the CD set here. And what that allowed us to do was turn several layers of insulation down on top of the parapets and create a continuous thermal lid over the building. There's some of our 4-inch layers of polyiso stacked up in those wedge-shaped spaces that went down the side of our building to the neighbors. And this gave us a really nice, clean shingle lap transition over our neighbors' buildings, and something I think will easily outlive any of us on the project team, which is exactly what you want in a low slope roof. So moving on to tying this all together, we did hit our mid-October deadline. We beat the snow, so that was a win right there. Because those assemblies accounted for roughly 40% of the total envelope area, and so they were important to get done in good weather under good conditions. So as Gary touched on here, the strategy for the air barrier is very simple. We're using the roof deck, the first floor deck, the steel framed front wall, and the existing masonry party walls as our air barrier. We don't have any large areas of air barrier or smart vapor control sheet membranes. We did use a lot of fluid applied smart vapor control and air barrier product. That was the Proclima Viscon fluid on the inside. And, with anything this large, these large open areas are relatively easy. But the challenge and the money is really in the corners and the intersections. So starting with the easier ones is the roof deck. I mean, this is just putting down sheets of Advantech and taping the seams. Like I said, we ran this long, we taped out over the edge, connected that to those zip sheathed gable roof trusses. We insulated with rock wool and steel, light gauge steel studs inside our facade structure, skinned the inside with 7/16 zip, and taped all those seams, taped over any fastener holes, taped or did fluid on all these brackets that attach back into the neighboring buildings. And the biggest and most daunting challenge was the masonry party walls. It's just the sheer volume that we had to address here. I mean, we have over 12, 13,000 square feet of 3 and 4 white brick walls to air seal. And, of that space, we had approximately 400 2x8 and 2x12 joist pockets, numerous abandoned chimneys, flues, legacy mechanical penetrations, and then just thousands and thousands of linear feet of these nailer strips that happened every 7, 8, 9 courses on all 3 floors. So, an important part of the program for the owners was the desire to sew as much of the interior brick as possible in the finished spaces. So even if it had to be coated with an air barrier product and then painted, we really had to be conscious of what we could get away with, what was the appropriate level of intervention to get us an air barrier and meet our aesthetic goals. So Gary's office developed this masonry repair document early on, which was, invaluable for getting us a quick post-COVID shutdown restart, getting some masons in there, and getting a head start on parging, pointing, infilling windows that we were abandoning, and opening up windows that we needed to make new openings for. So, of this list of challenges in the masonry walls, pocketed floor joists are high on the list of problems to solve. We spent a lot of time going through the space joist by joist, cleaning up old mortar blobs, pulling nails, tucking and parging around each penetration. So with the unique sequence of original construction, our second floor ceiling, third floor, it used to be the roof. So it's framed with like a double 2x8 cockloft assembly where only the bottom members were pocketed into the masonry, and then the upper members were stood off with 1x6s, and they stopped short of the party walls. So our masons spent a lot of time and effort parging the perimeters of the floor assemblies to make sure that we were airtight in what was really the most vulnerable area here, and an area that we'd be covering up later. So we needed to make sure that it was right and that we weren't burying any problems that we wouldn't be able to chase down in the future. Jump back here. After a few bays of trying to parge this condition, we realized that a far more humane and sensible approach was to cut back that top joist and stand that off with some new structure and give the guys some room to get a trowel full of mud back in there and get a much better job. There we can see getting started with that. Something else that we needed to clean up was the collateral damage of taking the facade down. So here's the condition to each neighboring building, sort of a before on one side and after on the other. And this picture on the left, I really like this because it shows how much open space there is in what's considered by a lot of people just, it's a solid masonry wall. There's no way that air is going to get through there, but there's quite a bit of room for air to get through there. So again, the guys spent a good bit of time working their way down, parging over all these busted up brick ends and tightening up to the neighbors, which really paid off in the end when we were able to make some pretty clean and solid transitions around the brackets here at the steel up front and not have air leakage problems. So one of the big things that we really had to figure out here was determining how much is enough effort, and getting everyone trained up to taking on sort of a new task that had a very it was a judgment call as to when do you stop, when's good enough, right? So we had a lot of places like the nailer strips that I showed earlier that were pretty straightforward and easy. There were just a lot of them, but it's a bed joint, pretty easy. Likewise, we had an untold number of pinholes, hairline cracks, little things that we could pretty easily rely on our fluid applied product to fill. But we also had countless places that fell in the middle, too big for one approach, too small for the other. And in the end, what it boiled down to was just taking a methodical approach to a big project, paying close attention to details, keeping track of what's been done and what hasn't been done, and just keeping your eye on the end goal. So when it came to the fluid applied air barrier products, we found that the best people for this task were the paint crew. Since they already had the equipment, they're used to being meticulous about prep, finish quality, and coverage, which are all important for this application. They didn't know anything about building science or air barriers, and to a certain extent, they don't need to know a lot, but they've got a new exposure to a new skill, new products, and doing something a little bit different than what they've been doing.
Hey, Norm.
Yes.
We're gonna have to wrap up soon.
Okay, sorry. How much time do we have?
Not much. A couple minutes, maybe.
Okay. All right. So after we cleaned, repointed, cleaned again, sprayed, and back rolled 2 coats of Viscon, touched up any last problems, we were actually able to get to our first coat of finished paint. Here they are with the fluid applied, and then here's our lead carpenter going through with a grout bag, checking the last bits that we couldn't get with the fluid. We'll jump ahead real quick here to where we're at now. Just kind of talk about the air tightness end of things, where Gary summarized the thermal, and we've been able to start doing some blower door tests, trying to get things slightly tighter than they had been. We were able to just go over our window openings with plastic to get our building to pressure, and using just simple tools like I regularly use this little flare dongle for iPhone or iPad to detect air leaks. That's not working so well now because the weather's warming up. It works better when you have maybe a 20-degree delta T from inside to outside. There's also just very simple things with running the blower door and using a smoke pen to trace leaks, or putting your hand over suspicious areas to see if you feel air. So last year when we started this, the PHPP had roughly settled to where it was going to be, and we figured that our estimated leakage area, or free open space that we were allowed to have to still meet that one ACH 50 threshold for EnerPHit, was about 290 square inches for a building volume of about 128,000 cubic feet. So that works out to a cumulative open area of about 3 sheets of 8.5 by 11 paper. And this is my first all masonry building to air seal, so I didn't really have a good frame of reference for how difficult one ACH 50 would be to hit in this situation. And when our certifier mentioned he thought that 0.3 was going to be easily achievable, I was pretty nervous about that. But turns out just having plastic over the windows and good attention to detail to big areas actually works out pretty well. And we're currently sitting at over the threshold, but we still have over 1,000 square feet of envelope area that's just plastic. So I'm confident that we're going to get well below our 1 ACH 50 threshold here in the next couple of weeks as all of our windows and curtain wall goes in. And I will cut it off there, and hopefully we have a few minutes left for some questions and comments.
Okay.
I think we have a few minutes remaining between now and our next session. So if there are any questions, feel free to unmute yourselves or use the chat.
We also have Kate Kennedy and Joel is online with us too. So Joel Morrison. So if you got any questions from the community or owner perspective, they're also available.
I don't have any questions, but I would say great job, Gare. And
thanks, great.
I appreciate your abilities.
Thank you.
Great. Well,
Yeah,
thank you all.
we can provide a link to that video that only got half shown. So I don't know what happened there, but we'll get that out to you.
Well, thank you all very much for joining us as presenters today. This was a very interesting topic. We really appreciate your time. I want to thank Langen and Carly Davis for being the session sponsor as well. And thank you to all of our attendees. With that, I think we will close this session.
Okay, thank you.
Take care, everyone.
Thanks.